mystifying world of animals, nothing is more intriguing than the strange form of understanding which is in animals from birth. We call it instinctive behavior. Shared by every member of a species, this innate knowledge is as distinctive as the physical appearance of that species. Through the millions of generations, precise patterns of behavior have been programmed into the brain and the nervous system of every newborn individual. Even if raised in isolation, a spider will spin a web as though by blueprint, in keeping with the strict specifications of the species. In the early morning dew, the web of the garden spider glitters like some fragile necklace. Every species of spider creates its own distinctive web. Some have wondered if the spider is partially inspired by a sense of order and of beauty. But the spider does not reason why. Like a tiny living robot, it will spin its complex web in strict adherence to some unvarying plan programmed in her brain. With electronic microscopes, researchers at the University of Kiel in northern Germany are probing into the secrets behind the structure and the functions of spider webs. Professor Ernst Kuhlmann hopes to penetrate the spider's hidden world, to learn just what motivates and guides these tiny architects. Magnifying the web 100 times reveals that each gossamer thread consists of many thinner strands, twisted tightly together.
Das wäre also im Prinzip das Gleiche, was wir jetzt oben im Mikroskop sehen.
From the insect's silk glands, threads emerge from tiny tubes before being woven together. Using a light box, Professor Kuhlmann photographs step by step the actual construction of a web. In the box, a tropical spider, a master architect called Nephila. The spider begins its web in the dark of night, when no pictures could be taken. The slightest ray of light would have disturbed it. After the first thin strands forming the foundation are in place, the spider will continue spinning, even through short periods of picture taking. The thread spun by the Nephila is less than half the thickness of a human hair. Now the Nephila must connect each and every diagonal thread with dozens of cross strands, creating a delicate network, a series of rectangles almost identical in size and shape. Now in a spiral movement from the outer edge to the center, a sticky thread is attached at intervals between the spokes. This sticky thread is what the web is all about. It's the trap from which few insects ever pry themselves loose. All the details of the web's construction have been blueprinted in the spider's tiny brain since birth. When instinctive behavior orders the spider to build, it cannot deviate in a single detail until the trap is complete. Only with the web can a spider catch its food, for it cannot fly, but must live on prey that does. For the Nephila spider, this web is life itself, its source of food. As automatically as it spins its web, the spider will bite its prey to paralyze it. To secure it before it's consumed, the fly is wrapped in a silken shroud. All this the spider does so that she and her species might survive. But the great mystery has not yet been solved. Is there within that brain any glimmering of understanding about the trap it weaves, about the power of the sticky threads, the poison of her bite? Or is the spider nothing but a living machine, programmed to kill? In the daily drama of nature, even color has a purpose. In this tank divided by an opaque pane are two tilapia fish who cannot see each other. It is a time of courtship, a time when these males wear their most beautiful colors. Though he has no mate, each instinctively builds a nest, and each feels safe in its territory. When the opaque wall is removed, a transparent pane will still keep them apart. But as soon as they see each other, they try to attack, for each considers itself the rightful owner of the territory. As the two males duel, their colors deepen, like war paint designed to intimidate the enemy. When the transparent pane is removed, a battle begins. Each is determined to defend his breeding area, his private property, his territory. They threaten and attack. Their colors proclaim their right to sole ownership. Produced by countless pigment cells, it is a challenge, a battle cry. When the mood and status of a fish changes, hormones and nerves activate the expansion of certain colors in the fish's skin. This unique form of animal behavior is instinctive, shared by every member of the species. It is beyond the power of any individual to control or change. Ultimately, one of them yields, giving up its claim to the breeding area. Its new status is reflected in its color. It is no longer the owner of territory. Dark stripes, like a white flag in human warfare, identify the loser. The winner keeps its territory and the colors of a homeowner. In a second tank are two other tilapia, both of which wear the color signifying ownership of territory. But there is no fight, for they are male and female. They are courting and they share their territory. Together they chase away intruders to protect their fry. Tilapia are cannibals. They eat the offspring of their own kind. The intruders are defeated and take on the dark stripes of losers. All that remains for them is a small corner of the fish tank. To us, the brilliant colors of a fish have always seemed a whim of nature, beauty without meaning. But to the fish themselves, the range of colors and patterns is a semaphore, signals for survival. More than 5,000 species of songbirds serenade the world. Some have a repertoire of a half a dozen tunes. Some have 10 or 12 distinctive calls. The male Shama bird's song proclaims, "This is my territory. Here I raise my young." Ordinarily, the Shama sings his songs in the tropical forests of Asia and on the islands of Indonesia. But here in a man-made nest box, two Shama birds live in the trees of the Bavarian woods. Here is the research center begun by Konrad Lorenz, pioneer animal behaviorist. A researcher hopes to learn how the Shama birds who claim this territory will react to the song of a strange Shama bird. A loudspeaker is placed in the very center of their territory. The young student already understands the meaning and the purpose of the Shama's various songs. On the tape recorder, a male Shama bird proclaims his territory. The rightful landlord is sure his territory is being invaded. He issues a threatening call. His call means, "Keep off. Here is where I hatch my young." the song of the strange Shama continues, and the territory owner keeps sounding its warning call and searching. Instead of a strange Shama, it finds a strange object. Now the loudspeaker is replaced by a live male Shama, a real invader. Now the call is genuine. Almost immediately, he is discovered by the owner of this breeding territory. The free Shama tries to drive off the intruder by fluttering around the cage and increasing the volume of his warning song. Attracted by the singing and the commotion, the female Shama leaves its nest and begins to sing to the strange male. Now she in turn is attacked by her own mate and driven back to the nest. Scientists believe that most birds are born with an innate knowledge of their species' song. Whether raised by their parents or raised alone, at the appropriate moment, the appropriate song seems to well out, to proclaim territory or to lure a mate. Scientists also believe that birds sing when they are free from fear and anxiety. Birds do sing for joy. Unlike other animals, we seem to be guided by conscious reason. We pride ourselves in our ability to think, to make decisions based on logic, on our own free will. But partially due to our studies of animal behavior, we're beginning to realize that we too are creatures of deep-rooted instinctive actions. These may not be the sole determining factors of our lives, but they are there, somewhere in our subconscious. Now, to understand more completely our own behavior, we must understand those basic instinctive patterns that we share with other creatures.